Hi, so I'm just going to be working on game 4 from prep test 86. So we have a medical clinic assigning doctors to shifts for the next 7 days with one doctor assigned to each day. So we do have 7 days in a row. So that part is relatively simple. There is a bit of a twist here in that we actually only have 6 doctors. So each doctor is assigned to at least one day, which means that one of the 6 doctors is going to be assigned to 2 days so that we can have one doctor per day. Okay, so that is a bit of a distribution issue as well, right? So I think of any kind of distribution issue as being that we have a different number of players from positions. So in this case, we have 6 players, we have 7 positions. We do know that each of the players is going to be used at least once. So that means that 5 players will each be used once, and 1 player will be used twice. And that's how we're going to get 6 players to fill 7 positions with these rules. Okay. All right. So that's our starting place with our positions and distribution. Okay. And then our players are G, H, K, L, N, P. I'm actually gonna switch these around because I like seeing my players listed above positions. It's just a personal preference there. All right, and then we get into the rules. Okay, so the doctor assigned to Sunday must also, the doctor assigned to Sunday must also be assigned to Saturday. Okay, so this is going to be Sunday to Saturday, right? So the Sunday and the Saturday are going to be same. Sunday, Monday, Tuesday, Wednesday, Thursday. Okay. And the Saturday and the Sunday will be the same. Okay. So this will be the Saturday, Sunday player. Graham will be assigned to exactly one day. Okay, so that means that, so if Graham is once, then Graham is not assigned to the Saturday, Sunday shifts. The day to which Graham is assigned must be immediately before or immediately after the day to which Copel is assigned. So we either have GK or KG. This does not prevent K from being on Saturday and Sunday. Okay, so if Graham is on Friday, for example, K could be on both Saturday and Sunday, and the day to which Graham is assigned is still immediately before a day to which Copel is assigned. And so that's significant. Okay, so the day to which Graham is assigned, singular, right? That's specific, right? The day means a single day, whereas a day could be one day out of many potentially. Okay, so if it said the here, then we could actually say that K is only on one day. But using that different article there, that's that part of a sentence is called an article, right? That type of word, and this is not specific, right? So we just know it's one day, but it could be one of many. And we can also see a day there, right? Rather than the day, right? Okay, so Herrera cannot be assigned to a day immediately before or immediately after a day to which Nelson is assigned. So similar rule, but just that they can't be side by side rather than they have to be side by side. So have to cross that out. And then Park must be assigned Tuesday. So that's very handy. So now we know for sure that Park is not going to be the Saturday, Sunday shift either. Okay, so H could be, but then that's really going to limit the position of N. N could be, but that would limit the position of H. And K could be. L is wild. We don't have any rules so far for L, so we may want to put a little asterisk by L or circle it or something in our diagram just to remember that it's there. Okay. All right. Sorry, these videos seem to always be a bit tired when I'm doing them, so I'm just yawning a lot. Okay. If Liedem is assigned to Wednesday, so we have a question-specific condition. That was on Wednesday. Then which one of the following could be true? So that means that we're looking for a possibility. We can also use process of elimination here and eliminate the rule breakers. Okay, so if L is on Wednesday, that's our first step. So we have P and L 3 after. Okay, so now I'm kind of going to start thinking, all right, well, I do need to have a buffer between H and N. So yeah, H and N, those ones maybe seem a bit less likely to work. But let's just go in order. So G assigned to Monday. So if that's true, then K has to be assigned to both the first day and the last day, right? Saturday and Sunday. And then the remaining players are H and N, and then they would be stuck together in the remaining two positions. So that's not going to work. So we can eliminate A. Okay, so that does tell me that K can't be Saturday, Sunday, unless G is in a different spot, so that H and N are in different positions. So this this could work. Okay, that's possible. Or we could just switch the positions of H and N. But we can't have G on Monday. Okay. So we do have a couple of acceptable solutions here where L is on Wednesday. H on Sunday, let's see if we can make that work. H, all right, we have to keep H away from N, and then we're supposed to put G and K together. So yeah, that's not going to work. So we can eliminate B as well. So we're supposed to put G and K side by side, but we wouldn't be able to do that in this third one here. So that's not actually an acceptable solution. Could we have K on Friday? So I'm giving that a go. If K is on Friday, then we're going to have to put G next to it, but G would have to be on Thursday, and then we would have PLGK there. This would be Sunday, Monday. And there's Saturday. H and N can't be together, so there isn't going to be a way to make that work. And then N being on Sunday, we actually don't have We have a pretty good idea that that's not going to work either already, right? So just show why that doesn't work. Okay, so there, and then we would have to put H here to keep it away from N, but then we have these two spots where G and K are separated. So looks like keeping H and N separated is really a big part of this. Okay, so what I would think about with this one in particular is when we, sorry, there's our 7 positions. So if I look at it as, oh, is it possible for me to put either H or N in the Saturday, Sunday spot? And then G and K have to be together. The other one would be here. That's just not going to work. So if H can't be Saturday, Sunday, and N can't be Saturday, Sunday, and we know G is only once, so it's never Saturday, Sunday, then the only one left is K at this point, because L is on Wednesday. Okay. So K has to be Saturday, Sunday, and we've already figured out what our options are if that's the case. And so Nelson being on Thursday, so I had the answer as soon as I made those worlds, but I sort of wanted to go through that process and just kind of demonstrate why each of the other answers is incorrect. But that's really how you can improve on this kind of game is recognizing that the player that's repeated in the sequence, that's one that you always sort of want to have your focus on to some extent, right? You always want to be questioning which player could be in that position, because knowing that gives you double the information, right? So yeah, something to keep in mind. Also keeping in mind, we have to have that block, that GK block is really important. Yeah, so I'm just going to pause here for a moment, but that's how I would do question 21 for this game. And we do have 2 acceptable solutions there. So that may prove handy for the other questions, but I will come back to this game in a moment. All right, so moving on to the next question. First, we can do the show answer. Okay, so we'll move on to the next one. Now we have if Liedem is assigned to Thursday, and it's a must be true question. So question specific condition. Again, they're telling us where the wildcard player is going to be. Here, the main difference is going to be now we have a space between P and L. And so we can use those guys as buffers. We can use both of them as buffers. So before, when they were stuck together, they could only act as a buffer between 2 players that can't be together, right? H and N. But now we could put H or N in between them, and then the other one would be able to be on Saturday and Sunday. So hopefully that makes sense the way that I'm describing it, but I'll show you in a little more depth with some examples here. So we still have P on Tuesday. We have a plane flying overhead my place, and then we're going to have L. Okay. So this space in the middle is what I'm talking about. So if I were to put H there, I could put N first and last in theory, but then we have the problem of our remaining spaces being here, right? So we're going to have G and K occupy one of these 2 spots, meaning that G is going to have to be, the inside spot because G can only be once, and then K would have to be the outside spot being Saturday and Sunday. So for sure, K will be
on either end. And then the question is just, do we have G? This would be H or N. So do we have G after K on Monday? Or do we have, we could put HN there, P, N, L, and then GK at the end. Okay. So I could also just write it out where we put H first, but we note that H and N could switch places. Okay. Okay, so the only difference is I'm putting G there versus there, right? And then H and N have to be separated. And here we have L acting as a buffer, and here we have P acting as a buffer. Okay. So we have more options for G in this scenario here where L is on Thursday. We have more options for everybody really because we could switch H and N like that. N, L, H, K. So these two are the same, except I've switched H and N. And the first one and this fourth one here are the same. I've just switched H and N. But you can see that if L is on Wednesday, we only have 2 options. But if L is assigned to Thursday, we have 4 options. Okay. And the thing that has to be true is that K has to be assigned to Sunday. And that's something we figured out kind of earlier on. But you can see the impact that that has on the other players, right? So once we've found what absolutely must be true in this case, we've made a deduction, we can look through the answer choices and we can find K assigned to Sunday there. Okay, so I'm going to remove that. Okay, and these are some acceptable solutions for our bank. Hi, chicken. Hello. Yeah? Are you having a good day, chicken? Mm-hmm. Okay. All right, one more question. Yep. All right. Mm-hmm. Yep. Okay, any of the following could be true except. So for a could be true except question, that means we're looking for something that must be false. And we have 4 answers that are possible. And we have to eliminate them. And then the exception, the thing that's not possible, is the thing that we're going to choose. All right, so we can actually kind of go through some of our acceptable solutions here and do some eliminations based on that. So G assigned to Friday, we have an example of that. We have multiple examples of that actually. So we know that that could be true, so we can eliminate it. H assigned to Sunday, we haven't tried that yet, but H assigned to Friday, I do have an example of that here. K assigned to Sunday, we've got a whole bunch of examples of that. And L assigned to Friday, we don't have an example of that, but we might suspect that that's possible given that L is wild, but we would actually want to try between these two. So let's try to put H on Sunday and see if I can make that work. So we've got H on Sunday, we have to have P here. 1, 2, 3, and H. So sorry, H would be on Sunday and Saturday, of course. And then what we need is we need G and K to be together, but we also need to keep H away from N. So let's see. We could put G and K here, put N here, and then use L as filler over here. So L, and then G and K, those guys together, and making sure that H and N are separated. That should work out just fine. So that appears to be an option. Let's see what's wrong with putting L on Friday. Okay, because it looks like H can be on Sunday, which would mean we would eliminate B and E would be the correct answer, and it would be the exception, the thing that must be false. So L is always on Tuesday, L on Friday. Okay, so now we need to put G and K together, right? So if we put them together here, K has to be on Sunday or Saturday and Sunday, right? So Saturday as well as Sunday. So we would then end up with KG, P, two spaces, L, and then K again. But those two spaces would have to be filled with H and N. If instead we put G and K between P and L, then we only have H and N left. And we either have HN, PGKLH, or we have NH, PGKLN. And neither of those is allowed. So we do end up with E being the impossible answer choice, meaning it's the correct answer. So yeah, so that takes us to the end of this game. I hope that that's helpful. Again, there is a bit of a distribution thing here, but I think it's also sort of recognizing how that is going to relate to the rule where G and K are together and H and N cannot be together. And so there's that idea of who are we going to use as a buffer between H and N? Hi, chicken. Hi. Hi. Okay, come on. Alrighty, so yeah, let me know if you have any further questions, and if you'd like any follow-up on this game, yeah, you can let me know about that or similar games. Okay, all right. I will talk to you later. Bye.